The next special angle we're going to look at is still in, we'll start in the first quadrant again, and this time we're going to look at 30 degrees. So 30 degrees equivalent in radians would be pi over 6. We know from when we looked at the 45-degree angle that if I have and let me draw this so that maybe that'll be our angle, reference angles will be clearer. We know that if we are here at a rotation of 30 degrees, then we would also be in the third quadrant down here. We would have an angle rotation off the x-axis in the positive direction of 30 degrees. So both of these are 30 degrees. We just know that this angle in the first quadrant is called the reference angle. And equivalently, we would have these values here in both the second and the fourth quadrant, where if I rotate to 180 and back up 30 degrees, I'll have my angle of rotation using reference angles there. Or if I rotate all the way around 360 and then back up 30 degrees, I'll be here again. So let's see if we can fill those values in using reference angles. If I'm thinking in the second quadrant here, again, just talking about degree measurements, I'm going to rotate 180 and then I'm going to subtract or back off 30 degrees. So 180 minus 30 has to be 150 degrees. Remember, if we're in the second quadrant, we are going to subtract from 180, whereas in the third quadrant, we're going to add to 180. So 180 plus 30 is 210. And then in the fourth quadrant, we subtract from 360. So we rotate all the way around to 360, we back up 30 degrees, and we're here at 330 degrees. Now, how does that translate into radians? So remember, we're letting the denominator of our reference angle guide us on how we determine this. So if pi over 6 is the reference angle, then one rotation here to pi would have to be 6 pi over 6. So we know that if we are in the second quadrant, we're going to subtract from the x-axis. So 6 pi over 6 minus pi over 6 gives me 5 pi over 6. So 6 minus 1 is 5 pi over 6. Equivalently, we would add to get the value in the third quadrant. So 6 pi over 6 plus pi over 6, or 6 plus 1 would have to be 7 pi over 6. And then if we think about the fourth quadrant is, what is the equivalent to 2 pi? Well, 2 pi would be the same thing as 12 pi over 6. So I'm just taking the denominator and doubling it in essence, right? 12 divided by 6 is 2, so I know that that would be correct. And if we rotate all the way around to the fourth quadrant, we would subtract from that. So it's 12 minus 1 has to be 11 pi over 6. So that's how we're coming up with the fractional values, or the radian measure, for the unit circle. And now let's go back to, let me get rid of some of these lines here. Let's go back to determining the ordered pair. So I'm going to put one more line back on here. Okay, so let's focus over here. We have this, and I'm going to make it look more like a triangle because it's based on our triangle. So I have a 30-degree triangle here, and if I create a right triangle, if this is 30 degrees and this is 90, then this angle up here has to be 60 degrees. And previously we learned that if we have this special triangle, then the legs and the sides on a 30, 60, 90 triangle would have to be 1, 2, and square root of 3. And those are the just the dimensions that we know from before. Now, again, if we have a triangle who starts out having sides with this dimension, and I want to scale this triangle so that it fits on my unit circle, I need the hypotenuse of this triangle, which is the radius of the circle, to be a 1. So again, I would divide the hypotenuse by whatever it is. So 2 divided by 2. That gives me the 1. But I can't scale only the hypotenuse. I would have to scale every side in here. And you can see that when I divide every side in here by 2, I now have new dimensions on this triangle. That's a 30, 60, 90 triangle, of one side in the horizontal direction being square root of 3 over 2, and one side in the vertical direction being 1/2. So relating that over here to our triangle, again, if I were to drop this down, you can see that I now have that 30, 60, 90 triangle. So moving in the x direction, we are going to move a value of the square root of 3 over 2, and in the y direction, it would be 1/2. So those are the new coordinates for our point that is traveling along the edge of this unit circle. And we know from previous examples or previous problems here that this ordered pair isn't changing, right? That doesn't change because whatever reference angle or whatever acute triangle I've created in the other parts of the unit circle doesn't change how far I'm moving in the x direction or how far I move in the y direction. The only thing that changes is the positive and negative sign. So if I'm in the second quadrant, x has to be negative. So negative square root of 3 over 2 and positive 1/2. If I'm in the third quadrant, they're both negative. So negative square root of 3 over 2, negative 1/2. In the fourth quadrant, x is positive, but this time y is negative. So that is our values for pi over 6. The last set that we want to talk about is now, if I have 30, 45, I now want to address the 60-degree angle that we have here. So 60 degrees in the first quadrant is going to give me 180 minus 60 would have to be 120 for the second quadrant. Down here in the third quadrant, we would have 180 plus 60 or 240 degrees. And then in the fourth quadrant, remember we subtract off of the x-axis, so it's 360 minus 60 or 300 degrees. Translate that, or let's find the equivalent radian measure. And for 60 degrees, the equivalent radian measure is pi over 3. And you just have to know that one. Of course, you can always find it using converting radians into measures using our formula that we had before. But in terms of translating this now around the unit circle, we're again going to let the denominator here of our measure guide us. So if we're talking about the second quadrant, we're going to be subtracting from pi. So pi in terms of thirds would be 3 pi over 3. So I'm going to rotate all the way around to 3/3 minus 1/3 gives me, or minus pi over 3 gives me 2 pi over 3. So we now have 2 pi over 3 here in the second quadrant. Similarly, down here in the third quadrant, we're going to add 1/3 to 3/3, and we would be at 4 pi over 3, right? So 3/3 plus 4/3 now gives me, or 3/3 plus 1/3 gives me 4 pi over 3. And then thinking about the 2 pi. So 2 pi is the same thing as 6 pi over 3, right? 6 divided by 3 is still 2. And then if we rotate all the way around and then subtract 1, so minus pi over 3, we would be at 5 pi over 3. So there are the angle and radian measures as we are moving around the unit circle for our 60 degree or pi over 3. So if we have, now we're going to think about a 60-degree triangle. If our angle of measure is 60 degrees here, and we made a right triangle, by the way, then this measure up here has to be 30. We know that the short leg is 1, the hypotenuse is 2, and the other leg has to be the square root of 3. We've already determined that if we are scaling this entire triangle back so that this hypotenuse has now a radius of 1, we would have to divide everything in there by 2. And you can see now that in terms of what we just talked about, our measurements for these sides have switched, which is where students really get these two angles mixed up. So now in the horizontal direction, we're moving 1/2. So that's x. And in the vertical direction, we're moving the square root of 3/2. Notice that when I look at the 60-degree angle coordinates and the 30-degree angle coordinates, they're similar, right? That's, again, where students seem to get those confused. They get them switched. So we can go in and we can fill in the rest of the coordinates here. We know that these ordered pairs are going to be the same as we move around the unit circle because the dimensions of my triangle don't change. The only thing that changes is the sign on x and y. So in the second quadrant, we are negative for x, positive for y. In the third quadrant, we're negative for both, so negative 1/2, negative square root of 3/2. And in the fourth quadrant, we are positive for x and negative for y. So notice that if we can learn the unit circle, let me try that again. If we can learn the unit circle for the first quadrant, everything else is the same. We know from previous lessons that when we are thinking about the sign of our function values, right, we have everything here. It depends on where our angle is falling in the unit circle. So or on the coordinate system, quadrants 1, 2, 3, or 4, we know that if we can, or I'm hoping that you'll see that if we can learn the first quadrant here, then you can just reflect those values around to understand, using reference angles from the first quadrant, what the rest of the angle measurements are going to be. So again, it's work smarter, not harder, in learning the first quadrant, because that really tells you everything else for the remaining quadrants.